without further ado, let's jump in. I think we were introduced personally. Let's do a little introduction of Traefik Labs as a whole, who we are and what we do. Right now, Traefik Labs is widely recognized around the ingress controller, API gateway, and API management space. But what we are really proud of, what we do best, is to provide usable, very user-friendly, good user experience on managing things, no matter where you run it, which environment, and so on. We got you covered. This is also the case why we are being recognized throughout different online platforms and advisory agencies, but also we are the top 15 Docker image on Docker Hub, and we can boast for the most GitHub stars in the API gateway context for 5 or 6 years altogether. So we are here to get you covered, no matter if you are running your environment on a virtual machine or in any Kubernetes distribution, any Kubernetes managed or self-hosted cloud provider, hybrid architecture, anything. It's not a problem with the Traefik tools. We provide different tools all around APIs and exposing traffic from different environments. And for that, you probably know the best the open source application proxy, which is a versatile tool to expose services running in various environments. You will find all these information on our website. In the pricing menu, the comparison includes the key highlights I'm showing as well, so you will find it later as well. Here, when you start with the open source free version, you can get to know how we do things, what we do best, and how GitOps and Kubernetes friendly the solutions are. And with just a simple Helm upgrade, if your needs evolve, if you want more features tailored towards API publishing, enterprise level capabilities, and so on, we have an API gateway. And with a simple Helm upgrade, within a minute, basically, with the license, now you are on the API gateway layer. And this builds on top of the open source proxy. So now no configuration is lost. Everything stays the same. It's basically just new features, new configuration options unlocked on top of what you already had. So no disruption towards Traefik. And even if your needs evolve further, there is an option for API management. And with API gateway and API application proxy built in, you get even more features tailored for governance on top of those capabilities that you had previously. Also, with a simple Helm upgrade within 30 seconds or something, you can get this experience. It contains a developer portal. It contains many things that can elevate your API governance. But I think this is enough for now on the high level. Let's dig deeper in the productivity side. And for that, I think I will share a little bit of personal experience with you. When I stepped into leadership roles across different infrastructure teams and engineering organizations, I encountered a recurring theme that the infrastructure was undocumented, even when run at scale. It basically felt like playing the Age of Empires. This is why the illustration here. In that game, you basically start with a dark, foggy world, slowly revealing the map as you move forward. But to me, this was not a game. It was our production data centers, and every inch or centimeter of fog basically cost us time, money, and sleep even sometimes. And I've seen teams as well to scared being to restart the gateway, the production gateway, not because of the downtime, but because nobody knew what was configured there, what rules it was enforcing, and custom configurations here and there only stored in memory and so on. And no documentation at all, no persistence. It was very fragile. And this pain has taught me something important to move forward, and we needed to stop firefighting and start thinking like a platform. And I had to build a team that could shift the mindset from reactive operations to proactive engineering. And this brings us to the use cases, the personas who are the most involved when you are running workloads and you want to expose them. And the frustration really hits first the publisher, the API publisher who builds, owns, and exposes APIs. There are many solutions there. They can employ many use cases it can cover, but this is something that I want to highlight, that there are two sides of the coin, because it's not enough to just publish APIs, but there are always consumers on the other side, developers or actual systems or machines, applications that are consuming these APIs. And the frustration here happens between the two of them, the governance here, where the API and API gateway and management solutions come in to bridge the gap and to make the interaction smooth, scalable, and secure as well. With a governance that doesn't limit, but empowers and makes productivity fly high. So I think this is what you should aim to provide governance that empowers. And this is why we discuss this as a key theme of today. But surprise, we are starting with the publisher here. Usually when you are thinking of onboarding, you usually think of developers, to onboard developers. But actually who face the problem of onboarding first is the publisher. When a new team member joins and so on, this is who will find the first struggles. Consumers come later. And because of onboarding of a new API into API management takes days or involves tickets and tribal knowledge, usually, the whole system breaks apart, breaks down. And by using declarative configurations and CRDs on the publisher side, you can make onboarding APIs and people to onboard to APIs, even on the publisher side, repeatable and GitOps friendly, because now you have no more fragile UI only setups, but everything lives as code. And for example, with the managed subscriptions, you can even predefine the consumer access flows. They probably don't even need to log into developer portals later. So onboarding can happen both on the publisher side and, of course, the consumer side. In the consumer side, the onboarding is all about empowerment to be able to discover the APIs, test the APIs, subscribe to it, copy the client code that needed to interact with that API. And what you need to aim here is to be able to achieve this without meetings, without waiting times. And this is how you can reduce API integration time from days to minutes. On the other hand, there is another aspect to onboarding, which is related to observability. Sorry, not onboarding, but productivity, which is related to observability. In this case, the API gateway that you centralize your traffic around. This is the gatekeeper of your infrastructure to secure, monitor, and to expose the APIs. And here, to provide visibility on what is happening in the runtime is essential. And this is why, for example, with Traefik, we put a lot of emphasis into providing metrics, traces, and logs as detailed as possible. And these days, OpenTelemetry rules this world. And this allows you to ship in a unified format to the tools you are most familiar with. Let it be a self-hosted option, let it be something that runs in the cloud as a SaaS offering. It doesn't matter as long as it can consume the metrics, traces, and logs now in a unified format. Then you will not fly blind. You will know what is happening inside your infrastructure, and you will be able to act on this feedback. And this is where the most benefit comes from, that you can get now a reduction in time to recover from outages, and overall to save money for the business. And there are always news that hits tech news that an outage caused this and that much amount, millions of lost revenue. This happens all the time because some teams did not have the proper checks or the proper governance in place, or something unexpected happened that they did not have the proper insights to catch these errors early before it reached production. And this is where really the observability provides a feedback loop that when you have everything configured as code, when you put everything into Git and apply to the clusters through GitOps and pipelines, you can correlate all these deployment events, all these changes to actual outputted metrics and traces and logs. And now you will see, you can correlate if you are getting suddenly 500 errors you are not expecting, you will see why. Because of a recent PR, for example, that was merged, that shows up as an annotation on your monitoring dashboard. And now you can go back to that PR, revert it quickly, mitigate the incident, and save the business. And then now you have time, because everything has code, to deploy it into, for example, a different environment, test it, and provide a proper fix, then reintroduce the change now with the fix, and have it. This feedback loop is essential. And if you do not have the time to manage all these infrastructures, all these tools to monitor everything, there are even options to go for observability as a service, fully managed API observability as a service. This is why we partner with, for example, Treble, that with a simple plugin installation on the gateway, you can get insights instantly and then act on these insights. Also check for different compliance problems, check for different security problems based on the observed traffic, or even we will talk about how you can leverage such capability further to observe the traffic, and which can it do for you, what can it do for you. And now the result is that debugging becomes proactive. Developers can now move faster. Incidents get resolved before they even happen, before they can even escalate. And to do that, there is, of course, a need to shift left. And this is why the runtime governance needs to empower, although it puts some checks into place, that these checks are for providing a safe guardrail to move within safe guardrails, to move fast within those guardrails. And this is why, for example, static analysis of your configuration can become very handy. Even in the GitOps pipeline, in your CI/CD pipeline, you can run some automation, pick errors, configuration errors easily, and fix them before it reaches the production. We provide some linters for that. But also it provides you an option to do some analysis of the change, like what is the impact of the change, because maybe the configuration you apply is totally correct, but you just changing one rate limit, one quota configuration, what you believe will affect only on a subset of users or on a specific group or on a specific user, but actually the change you make will affect more. And in this case, the static analysis can also provide you a semantic output, like who the affected users will be by this change. And this can really speed up also the pull request review flow, that now who reviews the pull request will not only see the hard fact, what the change was, but also what the impact is. So this really adds up to the governance aspect, that empowering people and making safeguard rails can be beneficial to unlock developer productivity. And in the previous webinar we had around security, we shared some facts, some key highlights, but from that, one point can fit really into the productivity picture as well, because of governance standpoint. And here, the number you see, I can imagine totally growing over the upcoming years, because as businesses need to move fast, the APIs are basically the backbone of the internet right now, and they expose more and more APIs. Those APIs need to be maintained, needs to adhere to standards, and if these are not maintained, these are forgotten, or for example, somebody just adds a rogue API that nobody knows of because it was easier to implement or circumvent something. These are what are called shadow and zombie APIs. And Treble, in their latest report, see from all the traffic they see that 35% of the APIs are rogue endpoints and zombie APIs, unmaintained APIs. These you want to get rid of as soon as possible. You will never know what data can be exfiltrated or what other system can be accessed through an unknown API, an unmanaged API. And this is where a governance which provides you a conformance check towards the open API specification can become really handy. With us, with Traefik API management, you can set one flag, for example, to block every endpoint outside of what is described in the open API specification. And all the methods that are not documented, those will become inaccessible right away you flip the switch on. And this setting is a very powerful one. Of course, you have you are able to fine tune it. Maybe you don't need it as a default option. Maybe you want to turn it as a default option for all APIs, but it's there. It's at your tool set that now you can leverage. So be aware that this exists, and now this technology is available. And I mentioned also that with observability as a service with our partners Treble, you can leverage the open API specification in another way. Because imagine that you are running legacy workloads, legacy systems, for long forgotten virtual machines and so on. Now you put the gateway in place and enable the plugin on the gateway. And now from the observed traffic, it is possible to build up the open API specification, and what was previously undocumented now becomes documented. And now it really completes this picture that from the observed traffic, now you have a configuration description, how it looks like, what is the API schema, what is the request response schema, what data travels. Maybe you need to make some manual adjustments, but it's a good start that previously would require a lot of effort. And from this observe mode, now you can flip the switch on and block all the traffic that is not known. So this really completes the picture of what you can do with an open API specification and why it's very important for governance and productivity as well. And for making granular access control even more fine-tuned, because even API management tools provide some level of granular access control built in. Within Traefik, you have option to configure open policy agent policies, OPA policies, that are basically allow you to act even more granular on the incoming request. You can tailor, even in this example, some claim settings that you want to enforce. The token issuance time must not be further than 5 minutes in this case, for example. And this really puts governance into a perspective that it's like a Swiss Army knife. Now you are not limited to what the tool offers, but you have basically an engine that you can fine tune, that you can provide these safeguards where developers will be able to move fast. And I'm sure all of you have heard around the AI boom that is happening these days. And I also want to mix it into the picture because of recent studies here, I'm using some data from the latest Stanford University study that AI is becoming more powerful each day. Previously, AI was just like a PhD thing. But now it surrounds us. It's everywhere. It's getting more powerful. It's getting embedded into everyday life. Like, for example, here is a chart that shows basically exponential growth in AI usage in medical devices. Like, you need to regulate all this powerful capability because with power comes great responsibility as well. And also, organizations are all in on AI. Previously, there was a stagnation, but now it's booming all the way. And with the various models available right now, we can see charts that compare US or Chinese models, for example, in this case. But for example, I'm in the EU, so I don't really care where the LLM model is hosted or who develops it. EU is regulated by GDPR with stricter data privacy constraints than any of these countries. So in this case, you want to be aware that where your data goes and what happens, and do you want to let all these data reach these providers, and maybe this is even a black box. You don't know what they do with your data you share as well. And with the responsibility as well, now there is a need for the responsible AI, which is a new term. And there are even benchmarks that are showing which models, which providers adhere to which responsibility model. And as you can see, there are some models that are not even conformant to any of the benchmarks. Like, it was trained on Twitter data, it absorbed anything the users posted online, and now how it can be responsible, how you can ensure that the inputs and outputs are safe to the business, safe to different users, different user groups you are serving. And this leads us back to API management, because AI is exposed as APIs. And since AI is at a boom, if you are looking at Hugging Face, for example, you can see that there are 1.6 million models available for consumption that you can run even self-hosted. And in this case, we see that AI endpoints are proliferating. They are sprawling. Companies are experimenting. Developer teams are experimenting. So all this necessitates a real fundamental need for API management, strong governance. And for that, your best tool to do is an AI gateway. Because it's exposing APIs, one could argue that how different it is from an API gateway. But in this case, the capabilities are tailored for LLM and AI related workloads. Now, specific features target these requests and responses. And also, takes some burden from you, like centralizing secret management, for example, that now you don't need to expose your, let's say, OpenAI API key to all of your mobile applications you are deploying to the public. But now you can put short-lived tokens. You can govern it with your identity provider. You can provide other things on top of what is available from the provider. So this is where the AI gateway can come into the picture to let you govern even internal and external AI models. And with AI inferencing, inferencing is basically consuming AI. There is another term related to that, AI training. We are not talking about training here, but inferencing when you consume the AIs. There are some new challenges emerging. First, there is the versioning challenge, because teams want to experiment with different models, and this can have a different effect on the user experience. And how it's consumed, clients break, do not break, how to make sure that these are not breaking, but still keeping the fast-paced evolvement, the improvement within the company as well. Or, for example, there can be another challenge on the scalability and cost-wise, because you burn through precious CPU and GPU cycles, and these days GPU is not cheap. You need to be mindful about what data you will process, how long it takes, how many cycles you burn through. And also the responsibility, as I mentioned, that the sensitive data or the generated inappropriate data, how you handle that. And for that, an AI gateway should have an answer that also empowering to users. And this is where, for example, the first one, the versioning challenge, can be solved with proper API versioning governance. Now that you are running local inferencing, now you are running cloud-based inferencing, you expose these services through API and AI gateways. But what you really want to do is to decouple the versioning from the exposed API from the model versioning. The API can have like a /v2 as in this picture, in this diagram, but the model running behind can be 0.2 or 0.3 or other minor versions or patch versions. The client might not need to know about the change you improved, but still, or if you are providing an unversioned API, you can experiment with any API version behind. But this is something I wouldn't recommend, but it's also possible not to break the clients, but keep the fast-paced improvement in your organization. And with the contract present and with the versioning present as code, basically, it really provides a shared responsibility model that the AI gateway can provide clients a view and also provide experimentation inside the cluster or upstream for the organization. So in this case, how you can do that? You need a powerful versioning system. And this is an example of what we have, for example, in Traefik Hub API management, that the versioning of the API can be done basically in any way you like. It's not limiting you, it's empowering you to do the versioning scheme you are familiar with the most, what your architects require to do, and so on. Traefik has a very flexible versioning system that can match on host or HTTP method, query parameters, any header, IP, authenticated user, anything basically what's in the request. So in this case, this really puts the power in your hands, that you can better manage the life cycle of APIs and AIs in AI workloads in this case, with less chaos and less incidents. And also, The second challenge, as I mentioned, can be related to scalability. And in this case, we provide semantic cache that you can leverage. In this case, it means that a prompt incoming, request incoming can ask for the same things, but expressed with different natural language, different sentences. But the distance, like the actual meaning of the request, is basically the same. So in this case, you can free up costly GPU cycles and serve the request from the cache. And also, it solves a lot, dramatically improves your latency, and it can become really effective on the cost, on the consumption wise, on your wallet or on your account, that now you are serving things that was already generated and not generating it again and again and again. And also on the responsibility side, there is a need to protect the information coming to the AI model, to the AI inferencing, and also coming out of that as well. So in this case, a content guard or a content firewall can help you, that it can also act on the request and response. It can block requests and response. It can mask data if you think it's the most appropriate way, not to block the request, but to mask the sensitive data. It can do it. And for that, we have a powerful rule-based system that it can act not only on the AI related workloads, but also on the API ones, because as you can see, you can configure JSON paths freely. And in this case, it's tailored for AI governance, but it can be also useful for API governance. And here we are using the Microsoft open source project Presidio as the engine, which does natural language processing. So you don't even need to write regular expressions. There are 35 or something built-in constants that you can apply. But of course, you can write your own regular expressions. It's not limited to that. But in this case, you don't need to express how a date looks like in different countries. You just set up, you want to block or mask date information or credit card information, and that's it. It understands the meaning of that sentence. So here I think I showed you many tools that you can leverage for governance, that empowers, that unlocks productivity. But I think talking is one thing, and theory is always a nice thing to go through, but we should see it live. And this time, Zaid will help us in that. I stop
Thank
the
you,
screen
Manuel.
share, and the
I
mic is yours.
appreciate that. Thank you. And yes, you're absolutely right. The best way to talk about something or to explain something is to sometimes show it. And that's exactly what I'm going to be looking to do over here. So can you guys see my screen?
Yes, we can.
Awesome. So before I get started, this is a video, but I do have the full setup locally. But I do want to go through this. I will talk about this and I will explain to you what we did. Now, in this demo, the idea here is to um, stand an infrastructure as code environment. So as you can see here, I'm applying my Terraform environment. Everything you're going to see in here is going to be infrastructure as code. So my entire environment from the cluster itself, as you can see, I have a K3D cluster being stood up to all the different toolings on that cluster from Argo CD, which will help us create specific packages, Traefik. You got Kserve for serving AI inferences, Mulvis, Olama. There's a ton of different tools that are being installed here. And now that everything is installed, now I did fast track through this. The setup takes around 3 to 5 minutes for it to be fully stood up. You can see here that I have access to my traffic dashboard. I can see the different routes. I can see the different services that are associated by default, and I see a middleware that I will talk a bit about later. Now, that middleware that we saw very vaguely is a middleware related to Trouble. And Trouble is the observability platform that Emmanuel mentioned during his talk. Now, in this demo, I will be looking at two different services. As you can see, I have created the first service, which is the Traefik Airlines feedback service. This is an AI service that will allow us to do some inferencing based on the feedback. You can see a bunch of middlewares associated with this service and route, and we'll actually delve into what each of those different middlewares or uh, those infrastructure code CRDs look like. So the first thing that you're seeing here is my JWT middleware. So the JWT middleware will allow you to authenticate your users based on identity provider. So as you can see here, we have the JWKS URL. The JWKS URL will allow you to fetch a JWKS from somewhere else, and we'll actually get to see that shortly. I'm also doing a couple of things, but let's first talk about the JWKS URL. So I'm right here. This is what the JWKS URL will return, and JWKS stands for JSON Web Token Key Set. This is how any provider can validate a JWT that was created by an identity provider or an OAuth 2 enabled provider to validate the validity, to validate the signature of the JWT. So it's just an RSA public key that's stored on your service. We're also doing forward authorization. The reason we're forwarding the auth token is because the next middleware is the OPA middleware, and we're actually doing some authorization based on that. The next two sections here are forward headers, which will allow you to forward a specific claim that's found inside your JWT to a header. So the header that we want is the role header, and the group is the claim name. And last but not least, we're also validating based on the claim. So we're only going to allow access for JWTs that have a group with the value customers in it. All right, so now that we talked about the JWT middleware, let's quickly talk about the OPA middleware. So the OPA middleware here is just an OPA rule that's going to allow access based on some certain parameters inside your JWT. Now, this is not restricted to your JWT. It can compute or make decisions based on different parts of your requests. In this example, I'm just specifically talking about JWTs.
And Zaid, if I can ask a question about this, I usually get the feeling that people are afraid of OPA in general. They need to spin up a new service they don't know about. Their language can have a different syntax that they are used to. But here, the OPA is not even installed as a separate component. It's built into the gateway, correct?
That is correct. The gateway will actually has an OPA middleware that will be able to understand those different expressions, those OPA expressions, and it will also inject the input, which is the request metadata. And based on that input, you can actually create your own rule set. The one thing that's actually really funny that I've noticed about OPA, it's because it's well defined, you can go to any LLM and actually ask it to generate the use case that you want, and most of the time they'll get it pretty well. So it's not as difficult to write some of these expressions anymore. And to be honest, once you get used to it, it's not the concept is not the most difficult. But as you can see here, I'm defining a couple rules. I'm defining the email verified rule and the recent token rule. So I'm checking if the email is verified and if the token is within the last 5 minutes. And based on that, I will give the person access. Now, before I go into my next section, I think the best thing that we can do is to show you what the GWT looks like. So I'm going to grab a request over here, and I am going to run that request to generate a GWT that I'm going to copy into gwt.io, and we're going to show you what the contents of that GWT looks like. And as you can see, we're looking at the issue that claim. This is the claim that we will be using to validate whether this has been created within the last 5 minutes or not. We're looking at the email verified to check if it's true. And last but not least, we're also looking at the group customers that will allow us to see if the customer or if the user belongs to the customers group. And now to going back to our last bit in our middleware, we have our secure middleware, which is a chain middleware. Now, a chain middleware will allow you to chain different middlewares together in a certain order, and those middlewares will just be executed in that order, and they can be referenced as a single middleware. Awesome. So, excuse me. The next thing that I want to talk about here is going to be the AI section. Um, So the AI section part of this feedback service. So in here in the AI section, we actually deployed what we call a content guard, which is what Emmanuel just described. So this is a middleware that will allow you to cleanse some of the data that's coming in or going out of your API, whether it's an AI or not. And you get to define a JSON path. You get to define the mask and the entities. Now, the entities are, as Emmanuel mentioned, I think there's like 35 of them that you can choose from. You can choose from the list. You can either mask or block, and the JSON path is over there. So once you set up all these variables, and once you have your engine set up, which as a manual, I'm also using Presidio, you will be able to block or mask some of the data that's going into your or out of your service. And last but not least, let's take a look at the route. Now, the route that I'm deploying here is going to have an inference service that's going to be deployed using the Kserve CRD. This is going to be a Hugging Face model that is going to return information about sentiments for the sentences that I'm going to provide it. So basically, I'm going to be submitting feedback, and this service is going to tell me, hey, this sentence has negative connotation or positive connotation associated with it. And last but not least, you can see that I have my route set up, and I have my secure, my feedback content guard, and my treble observability or middlewares all applied to this feedback airlines example. Excuse me. So the next thing that I would like to do is actually send some requests to the service. So as you can see, we can see that the feedback service is indeed loaded and it's up and running. So excuse me. And you could also see all the different CRDs that we mentioned. So everything has been loaded into the Traefik hub, the Traefik hub dashboard, sorry. And now I can actually start testing my service. Now, the reason why I ran the request for the access token again is because remember, this was only valid for 5 minutes. So what I did there was refetch a token so that it has not expired. And then I'm already sending my first few sentiments. So in this one, you can see that this person had a fantastic experience. And you can see that the prediction comes back with 0. Now, this service is in the early stages. In the future, we're looking to have it return, words associated with this this feedback. But just to start, this is what we have. Now you can see in the second example that I have location inputted in there. And for my third example, as you can see, all of those were positive examples. You can see that I have a phone number. So the expectation is that Traefik is actually cleaning all this data up as it comes in. Now have a couple more examples here for negative connotation. So you can see the predictions that are being returned are 2 for the few requests that I'm running right now. And the third request right here is the last negative connotation request. You can see all of them return 2, and each of them have different PII data associated. Now, on the right-hand side, you can see that I have gone into my Traffic Hub UI, and you can actually click on the debug logger, and you can actually see the different requests that you made, and you can see all the data that is supposed to be blocked or masked to be replaced by stars, which is exactly what we expect here. Now, I have one last example here. Now, I'm using the admin the admin username rather than the um, customer one. And this is just to show you an example of the um, authorization being rejected because you have the wrong claim, which the claim for this user would actually be the admins group rather than the customers. And that's why you can see that the result is 403 forbidden. All right, so now that we have talked through the feedback example, we also have another example, which is our chat example. Now, in the chat example, I have a web UI chat that is is up and running. This web UI chat will receive connections from Olama that will be managed through Traefik, and we'll be applying what we call semantic caching on top of that. So the semantic caching part is going to use the Olama vectorizer through the embedded text. And then it's also going to have the vector DB, which is Milvus, that will allow you to store that the vectorized data inside that database. So Traefik can go in there, figure out, so Traefik can go in there once it receives a request and finds the vector value of that request and determine the distance between that request and a different similar request, and then return semantic cache or cache that is based on the semantics of the request. I hope I explained that well, but we'll see how that works in practice. I also have my Olama service that is going to implement the observability middleware as well as the chat semantic caching middleware. So let's go back into the UI and let's actually open up our chat service. Now our chat service is going to be using Quinn 2.5 model. And we're going to go ahead and ask it a couple similar questions about traveling, as this is supposed to be a travel service assistant. So we're going to go ahead and copy the first question. Can you suggest some destinations in Europe? And it's going to go fetch that request, and it's going to give me a list of 10 places to suggest. Now, typically, if you ask the same exact question again, you will not get the same result. If you go to Chat GPT right now, and you ask the same question twice, you most likely will not get the same result, at least not exactly. However, because we're using semantic caching, right now I'm sending a separate request. As you can see, first of all, the request did not take that long to respond, so you can tell that there is caching associated, and you can see that the entire response is the exact same thing as the previous one. This is obviously because the two queries were actually very semantically similar. Um, Now, the way we can actually show that this worked is we can go back to our treble instance, and it can show us the different cache hits and cache misses on our different API chat calls, and you'll be able to see how close the cache distance is. So the first request that we sent has a distance of 0, and it was a miss because there was nothing else in the database. But if we go to our second chat request, you can see if I click on headers that the cache distance was actually 0.86 and the cache status was hit. All right, this is everything that I had for you guys.